Alright, welcome back. This is part 2. If you want the answers to questions 1 through 15, look at the other video. Question 16. If calcium hydroxide completely dissociates into positive and negative ions in water, then it is A. When you answer a question like this, first you have to look at the formula. Calcium hydroxide. If you were to write that out, we would have Ca, which is a positive 2 charge, and then OH minus is hydroxide. So OH minus, or hydroxide, has a negative 1 charge. We know calcium has a positive 2 charge from its position in the periodic table, and we know hydroxide has a negative 1 charge. Now, since hydroxide has a negative 1 charge and calcium has a positive 2 charge, for this to be balanced, we need to have parentheses around that and then a subscript of 2. So that's calcium hydroxide. So is that a base or an acid? If you said base, you're correct. Now we have to look at whether it completely dissociates or incompletely. A completely dissociating base is going to be a strong base. Now we've got its opposite over here. Notice the hydrogen in front of acetic acid tells us that this is in fact an acid, and notice that it partially dissociates in water. Therefore, this is a weak acid. Draw the pH scale below. Label the following. To do this, I suggest going to Google Images. Let's find that. And putting in something as easy as pH scale. Look, these days Google does your homework for you. It's sort of ridiculous. Look at all the pH scales that you can choose from here. God, this looks like a pretty good one. Pretty simple. Under getfreeweightloss.com. The acid and alkaline. Alkaline is like a British word for base. It goes from left to right, so acid on the left, base on the right, and then we have neutral water in the middle. Look at the background on this. Apparently science will help you lose weight without doing any work. No, don't believe it. Back to the homework. Which of the statement below is false? The only one here, let's see, strong acids almost completely dissociate in water, while weak acids partially dissociate. That is true. Strong completely dissociate, weak partially dissociate. Strong partially dissociate, as soon as you read that, you know that that's going to be false. Weak acids always have lower pH. That's also false. The pH is not determined by how strong or weak an acid is. And strong acids produce hydroxide. Hydroxide? No, hydroxide is for bases. So that is false. Oops, I just made a little French word. Down here, which solution is more concentrated? We saw this in class today when we were playing the game. The higher the number of moles, the higher the molarity, the more concentrated a solution is. So 10.3 molar sodium hydroxide is more concentrated than the lower number molarity. Now we've got strong, weak, and non-electrolytes, and it's asking what happens to a light bulb connected to those things. When we look at a picture of electrolytes, and I think I had that pulled up before, an electrolyte is anything where it dissociates in solution and allows electrical current to flow. So in a strong electrolyte that completely dissociates, like salt, you'll get a bright light bulb. A weak electrolyte would give you a dimmer glowing light bulb, and a non-electrolyte does not conduct electricity. So we would say this would give us a bright light, this would give us a dim light, and that would give you no light. If you're ever asked to make an acidic solution, make sure you always add acid. We say AAA, always add acid first to water. Make sure you do it slowly while stirring. You wouldn't just dump it on in there, otherwise it might splash. Then it says which equation is used for dilutions. Remember we learned this as VUM, VUM, and you have to remember that it's V1M1 equals V2M2. I'm going to make a separate video showing how to do dilution math in a minute, so just look for that in a little bit. Or, if you're having a really hard time with it, Google dilution equation. If you put in MV, you should find plenty of help on that. If you have any questions, send me a message or come in early tomorrow and ask. I'll be doing a short review before the test, so make sure you get there on time.